The minimum vertical clearance without an insulating barrier for an overhead conductor system, or OX, can be found in National Electrical Code, or NEC, section 110.34 and B. This section requires a minimum clearance of 8 feet, which is 96 inches. The minimum vertical clearance with a 1/4 inch thick insulating barrier is detailed in NEC section 110.34C, which states a minimum clearance of 4 feet, which is 48 inches. NEC section 110.34 provides additional details regarding clearance from the ground and other objects. Now let's consider the qualifications for a person to work on electrical systems above 600 volts. The baseline requirements include work experience, education, and training. Firstly, work experience. A minimum of 2 years of experience working with electrical systems over 600 volts is generally expected. Secondly, education and training. A high school diploma or equivalent is typically required. A certificate from an accredited training program focused on electrical work above 600 volts is also crucial. Furthermore, specialized training on the specific equipment and systems being worked on is essential. Several code references and industry standards are relevant. These include NEC section 110.3 A3, which addresses examination, installation, and use of equipment. Next, NESC Rule 121, covering qualified persons. Then, OSHA 29 Code of Federal Regulations, or CFR 1910.269, concerning electric power generation, transmission, and distribution. Also, the International Brotherhood of Electrical Workers, or IBU, and the National Joint Apprenticeship and Training Committee, or NJAC, provide standards and training. Finally, industry standards such as IEE Standard 1313, which deals with insulation coordination, should be considered. There are additional requirements that may include passing a written exam and demonstrating proficiency in several areas. These areas: firstly, electrical theory; secondly, safety procedures; thirdly, test equipment use; and fourthly, system operation and maintenance. Furthermore, ongoing training and periodic evaluations are necessary to maintain competency. In summary, working with high-voltage systems requires adherence to specific clearance requirements and stringent qualification standards for personnel. These standards are designed to ensure safety and prevent accidents when working with potentially dangerous electrical equipment. Firstly, it is important to emphasize the critical role that proper vertical clearance plays in preventing electrical hazards when dealing with overhead conductor systems. The NEC provides clear guidelines on the minimum distances required between energized conductors and surrounding structures or the ground. Adhering to these clearances is essential for maintaining electrical safety and preventing accidental contact or flashovers. Secondly, the use of insulating barriers can significantly reduce the required vertical clearance, as specified in NEC section 110.34C. However, it is crucial to ensure that the insulating barrier is of adequate thickness and material to provide sufficient protection against the voltage levels involved. Regular inspection and maintenance of the insulating barrier are necessary to ensure its continued effectiveness. Thirdly, the qualifications of personnel working on high-voltage systems are paramount to ensuring safe work practices. The requirement for a minimum of 2 years of experience working with electrical systems over 600 volts underscores the importance of practical, hands-on experience in this field. This experience allows workers to develop a deep understanding of the hazards involved and the appropriate safety precautions to take. Fourthly, education and training play a vital role in equipping workers with the knowledge and skills necessary to work safely on high-voltage systems. Accredited training programs provide comprehensive instruction on electrical theory, safety procedures, and the proper use of test equipment. Specialized training on specific equipment and systems is also crucial, as it ensures that workers are familiar with the unique characteristics and potential hazards of the equipment they are working on. Fifthly, compliance with relevant code references and industry standards is essential for maintaining electrical safety. The NEC, NESC, OSHA, IBU, and IEE standards provide detailed guidance on safe work practices, equipment requirements, and personnel qualifications. Adhering to these standards helps to minimize the risk of accidents and injuries. Sixthly, the requirement for passing a written exam and demonstrating proficiency in various areas highlights the importance of ongoing assessment and evaluation of workers' knowledge and skills. This ensures that workers have a thorough understanding of electrical theory, safety procedures, test equipment use, and system operation and maintenance. Seventhly, ongoing training and periodic evaluations are necessary to maintain competency and keep workers up to date on the latest safety practices and technological advancements. This is especially important in the rapidly evolving field of electrical engineering, where new technologies and techniques are constantly being developed. Eighthly, it is crucial to emphasize the importance of a strong safety culture within organizations that work with high-voltage systems. This includes providing workers with the necessary training, equipment, and resources to work safely, as well as fostering a culture of open communication and continuous improvement. Ninthly, regular safety audits and inspections should be conducted to identify potential hazards and ensure that safety procedures are being followed. These audits should be conducted by qualified personnel with expertise in electrical safety. Tenthly, it is important to learn from past accidents and near misses to prevent future incidents. Thorough investigations should be conducted following any accident or near miss, and the findings should be shared with all relevant personnel. 11thly, workers should be encouraged to report any safety concerns they may have without fear of reprisal. This can help to identify potential hazards before they lead to accidents. 12thly, it is important to recognize that working with high-voltage systems is inherently dangerous, and that even with the best safety precautions in place, there is always a risk of accidents. Therefore, it is essential to take a conservative approach to safety and to err on the side of caution whenever possible. 13thly, the use of personal protective equipment, or PPE, is crucial for protecting workers from electrical hazards. This includes items such as insulated gloves, sleeves, and footwear, as well as arc flash suits and face shields. 14thly, regular inspections and maintenance of PPE are necessary to ensure that it is in good condition and provides adequate protection. 15thly, workers should be trained in the proper use and care of PPE. 16thly, lockout/tagout procedures should be followed whenever working on de-energized electrical equipment. This involves disconnecting the equipment from its power source and placing a lock and tag on the disconnect to prevent it from being accidentally re-energized. 17thly, workers should be trained in the proper lockout/tagout procedures. 18thly, ground fault circuit interrupters, or GFCIs, should be used whenever working in wet or damp locations. GFCIs are designed to quickly disconnect power in the event of a ground fault, which can help to prevent electrical shock. 19thly, workers should be trained on the proper use of GFCIs. 20thly, arc flash hazards should be assessed before working on energized electrical equipment. An arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. 21stly, workers should be trained on how to assess arc flash hazards and select the appropriate PPE. 22ndly, rubber blankets and other insulating materials should be used to cover exposed energized conductors when working in close proximity to them. 23rdly, workers should be trained in the proper use of rubber blankets and other insulating materials. 24thly, safe work practices should be followed at all times when working with high voltage systems. This includes maintaining a safe distance from energized equipment, avoiding distractions, and communicating effectively with other workers. 25thly, workers should be encouraged to ask questions and seek clarification whenever they are unsure about something. 26thly, supervisors should provide clear and concise instructions to workers and ensure that they understand the tasks they are assigned. 27thly, regular safety meetings should be held to discuss safety issues and reinforce safe work practices. 28thly, a culture of safety should be promoted at all levels of the organization. 29thly, management should demonstrate a commitment to safety by providing the necessary resources and support. 30thly, workers should be empowered to stop work if they believe that it is unsafe. 31stly, continuous improvement should be the goal of every safety program. 32ndly, The ultimate goal of all safety efforts should be to prevent accidents and injuries. 33rd, by following these guidelines, organizations can create a safe and healthy work environment for their employees and ensure that they are protected from the hazards of high-voltage electricity. 34th, remember that safety is everyone's responsibility and that everyone has a role to play in preventing accidents.